Okay, I don't know what just happened. The camera went black. Anyways, so here we're going to differentiate a bigger problem. And you notice that there are both product rule and quotient rules here. So like I was saying, we're going to use the quotient rule first, okay? Because we're going to start by getting rid of this division sign. So we're going to use the quotient rule first. So that means you take the bottom as it is, and you times it by the derivative of the top. So right now I'm just writing d dx of this top because I'm going to do some side work and then plug things in so that we don't get lost with all of the work that we're doing. And then I'm going to subtract the top now, remember, big parenthesis. So the top, as it is, times the derivative of the bottom. Okay, please remember that these have to stay in that big parenthesis. And then all of that gets divided by x to the fourth squared. So the first thing that we have to do is we actually have to find the derivative of this, which you guys can see the derivative of this guy is we have to use the product rule. And then we're also going to find the derivative of that. So I'm going to start off by finding the derivative. So a little side work here. So side work, it's going to be more than side work. It's actually going to be pretty long. We're going to find the derivative. So d dx of this. Okay? Which means if you remember the product rule is going to be the first guy. So I'm finding d dx. I just don't want to write too much. So I'm finding the derivative of that guy right now. So what is the derivative? Remember, it's the first guy, so x squared plus x, times the derivative of the second guy. So times 2x minus 1, plus the second guy times the derivative of the first guy, which is 2x plus 1. We clean this up, so first we have to distribute, so this ends up being 2x cubed plus 2x squared minus x plus x, remember that this has to be distributed, and you notice that this is a trinomial times a binomial, so you have to be careful with that. If you want to do a little box and multiply that out, you can. So what you end up getting from this, if you were to do a little box to keep yourself organized, it's a lot easier, believe me. So it's x squared minus x plus 1 times 2x plus 1. So now when I multiply this out, I get 2x cubed minus 2x squared plus 2x, x squared positive minus x plus 1. And then what you notice is that these two are like and these two are like, so what we end up with is 2x cubed, negative 2x plus x is negative x squared, 2x minus x is plus x plus 1. So now I'm going to continue my side work by combining things that are the same. And you notice that this is 2x cubed plus 2x cubed, which gives us 4x cubed. The squareds is 2x squared minus an x squared, which gives us a plus x squared. The x's is negative x plus x, which actually cancels out. And then we're left with plus 1. I knew I made a mistake right here. Okay. Sorry about that. Let me fix this. So I made a mini mistake right here, so I'm just going to start over because I didn't even foil this part. I just kind of distributed something very random. So let's redo this. It's FOIL. So it's 2x cubed. Outer is minus x squared. Inner is plus 2x squared. And then last is minus x. I have no idea what I just did. And then this was correct. So what we get from this is 2x cubed minus x squared plus x plus 1. And then look what ends up happening. So when we clean all of this up, the 2x squared plus 2x, 2x cubed plus 2x cubed is 4x cubed. Negative x squared plus 2x squared is 1x squared. Minus an x squared, what happens to all of them? They're gone. Here we got the negative x plus the x. That is also gone. And then you're left with plus 1. Now this is not like the h's where this will always happen. Okay? So don't think that it does. So this right here is the derivative for this guy. Okay? And then the derivative of this guy, so dx of x to the fourth is easy. It's 4x cubed. So basically, what I'm going to be doing is I'm going to plug this in where the green is. I'm going to plug this in where the purple is. Okay, and then things are going to start cleaning up. So this was my side work. I'm going to box it up, and I'm going to continue here. So I'm going to bring this down exactly the way it is. So x to the fourth times the derivative of this, which we found was 4x cubed plus 1, minus all of that. And if you wanted to, you can multiply this out right now. Okay, and I'm not going to show you guys how exactly I did that, but, well, maybe I should. But I made a box, and I put the trinomial up here, and the binomial down here. And then when I multiplied it out, I actually ended up with a lot of things canceling out. And I'll show you in a second. So what do you notice? This is negative x cubed, positive x cubed, gone. Positive x squared, negative x squared, gone. So what are we left with? X to the fourth plus x. And then that gets multiplied by the purple derivative that we just got, which is 4x cubed. And all of that, of course, don't forget, is over x to the eighth. Now the rest of it is just cleaning it up and getting the correct answer. So the first thing I'm going to do is distribute this x to the fourth. So we end up with x to the seventh, or 4x to the seventh, plus x to the fourth, minus, I'm still working inside these parentheses, so I'm going to distribute. This is 4x to the seventh plus 4x to the fourth. All of that is over x to the eighth. So what do you notice happens? 4x to the seventh minus 4x to the sevenths, they're gone. X to the fourth minus 4x to the fourth, you end up with negative 3x to the fourth over x to the eighth. And then, of course, what happens to these exponents? Remember that this is negative 3 times x times x times x times x over x times 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 x. 1, 2, 3, 4, 5, 6, 7, 8. So That's gone, that's gone, that's gone, and that's gone, and we're left with 4 x's on the bottom. So guess what? Our derivative, so our dy dx is equal to negative 3 over x to the 4th. Now, the way we check this graphically, to check graphically, graph what you got, which is negative 3 over x to the 4th, and use the derivative function to graph the problem. I'll show you in 1 second. So in our calculator, let me delete this. So in our calculator, first I'm going to graph what I got. So under tab, I'm just going to graph negative 3, so control divide, negative 3 over x to the 4th. Enter. Alright, I did something wrong. So let's do tab, control divide, negative 3, and then x raised to the 4. There's my graph. You guys cannot see this. There's the graph. You can barely see it, but there it is. And now I'm going to tab, and I'm going to use the derivative function in my calculator. So basically, what I'm going to do is I'm going to go to the book button. I'm going to click that, and I'm going to get all of these options, and I'm going to go to number 4. You can barely see it, but then there's a derivative here. You can't see that. It's very hard. I don't know why. And I press enter. And here I'm doing a dx. So I got to plug that in. And then I'm going to plug in my original problem, which is control divide. We have parenthesis x squared plus x, another parenthesis x squared minus x plus 1, all of that over x raised to the 4. So basically my calculator is going to graph the derivative. I'll press enter, and my 2 graphs should be exactly the same. And they are. They completely overlap each other. And that's how you check your work, to check that what you got is the correct derivative. Okay? All right. Next, suppose, let me fix that. So suppose u and v are differentiable functions of x, and then they give you, they tell you that u of 1, which is the function, is 2, and its derivative at 1 is 5. And then they tell you that v of 1 is 4, and its derivative at 1 is negative 3. Okay? And now you want to find the values of the following derivative. So this right here is the product rule. And if you remember, the product rule says take the first guy times dv dx plus the second guy, v, times du dx. And here, what is u? U is at 1. Remember, we're doing all of this at 1. So here, at 1, u is 2. Times, what is the derivative of v? The derivative of v is negative 3. Plus v. So v at 1 is 4 times the derivative of u, which is 5. And then you do the math. So negative 6 plus 20, and that's going to give us positive 14. Pretty straightforward. This one is the quotient rule, but you're still using the same exact rule things here. So this is going to be the bottom. Remember, you always start with the quotient rule at the bottom. So v times du dx minus, in parentheses, u times dv dx, all of that over v squared. So v is 4 times du dx, which is 5, minus, big parenthesis, u, which is 2 times derivative of v, which is negative 3, and all of that is over v, which is 4 squared. And that's going to be 20 minus negative 6 over 16. So we got 20 plus 6, which is 26 over 16, simplified to 13 over 8. Done. Now this over here, you're not using product or quotient. It's literally just the sum and difference. So basically this is 7 times the derivative of v. Okay? So it's 7 times the derivative of v, which is negative 3, minus 2 times the derivative of u, which is 5, right? Because they're asking us to find the derivative of these two functions. And you remember, if there's a number in the front, that gets multiplied by whatever this derivative is. So this is negative 21 minus 10, and that gives us negative 31. Done. Okay, I'm going to do this last part pretty quick, but we talked about first order derivatives. May themselves be a differentiable function. And if so, its derivative is d dx. Correct? And you guys know how to find derivatives of the first order. So all of this box is not super important. Okay, sorry for the long pause. But we talked about how to find the second order derivative. So this, the derivative of a function, dy dx, gives us our second order. So d squared y over dx squared. See, the reason you don't square the d is because that is always there. Okay? And this is called the second order derivative. So moving on, it is called the second order derivative of y with respect to x. And of course, if the second derivative is differentiable, that means smooth and continuous, its derivative is called the third derivative of y with respect to x. And it's given by d cubed y over dx cubed. The name continue as you expect they would, and thus we denote the nth derivative, okay, as one of two ways, dny over dx to the n, or we can say d dx y to the n minus 1, which is equal to y to the n. And please don't confuse y to the n with a power. Okay, it still does mean derivative. So that's why I prefer using this one. All right, which brings us to the last example. Pretty easy. Find the first four derivatives of this function. So the first derivative, dy dx, is 4x cubed minus 21x squared plus 4x plus 0, right? The second derivative, so d squared y over dx squared, is 12x squared minus 42x plus 4. So you see, I'm just finding the derivative of the derivative. The third derivative is 24x minus 42. And remember, that is 0. And then the fourth derivative is just 24. And if we kept this going, the fifth derivative is 0. And then every derivative after that is also going to be 0. Now we'll do some examples of why we find the second derivative. It's more for real story problems, to finding the instantaneous rates and then the velocities and speeds and things like that. But for now, just know how to find the derivative using the sum and difference rules. Okay, longer than expected because of problem number 1, but you guys can fast forward through it.